In last lecture, we have seen static versus dynamic performance characteristic. What are the absolute standards and what are derived standards? What is accuracy? What is precision? What is uncertainty, responsivity, etc. Now we will begin with what is a linear characteristic of the system, non-linear characteristic of the system. Here, two pictures are shown. The first one is shown linear characteristic graph, and the second is non-linear characteristic of graph. Practically, I give you example of weighing scale. When I put 1 kilogram weight on weighing machine, it shows 1 kilogram only. So we can assume there is no error and system's output is directly proportional to its input. Then it is called as a linear characteristic of the graph. Its equation is y is equal to mx plus 0. The sensitivity is constant from 0 to full scale value. Then the calibration characteristic is linear and straight line passing through the 0. In a non-linear characteristic of graph, we can see the graph is passing, the output of the graph is not predictable when we apply to input. If we put 1 kilogram weight, it might show 1.5 kg. So the output is not predictable. Now, what is drift? Uh, I would like to explain you with a simple example of fuel tank. When your fuel tank is halfly filled, it shows 50% in a display. But after 1 year, it starts showing you 40% for the same half-filled tank. That change over time is nothing but its drift due to fuel gain due to its component inside. It is a slow variation in the output signal of the transducer, which is not due to any input quantity. It's primarily due to change in its operating condition. It is noticeable as a zero drift and sensitivity drift. Now, what is the threshold? First, we will see example and then we will see definition. If we apply 0.1 volt to any input and then output started showing variation in output. So the 0.1 volt is called the threshold of the instrument because if I give input as a 0.8, the scale of the output will not move. So it is the minimum input quantity that is necessary to cause a detectable change in output signal from a zero indication. In a digital readout system, threshold is an input quantity which is necessary to cause a detectable change in output signal from the zero indication. It is that input quantity which is necessary to cause a change of at least one significant digit in the output signal. Now we will see what is hysteresis. Before understanding hysteresis, we will understand what is ferromagnetic substance. So ferromagnetic substances are nothing but the substance which we put in a magnetic field, they get energized, magnetization, they get magnetization. In a ferromagnetic substance, magnetization is caused by external varying magnetic field. However, the magnetization does not change instantly with the applied field, but it lags behind. This lag between the magnetization and the magnetic field is known as hysteresis. For a system, output depends on input and past inputs also. Hysteresis means that the system remembers the past. The output does not just depend on what you do right now, but also depends on what you did earlier. See, we can understand this concept by the example of sponge. When You press response, it flattens. You stop pressing, it doesn't instantly go back to its normal shape, but it takes time. It bounces back. That delay is called lag. It is a similar like hysteresis. When you apply the magnetic field, the material get magnetized. When you remove the magnetic field, the material stays magnetized for a while. This memory of the system is called hysteresis. Think of a system where input is equal to magnetic field and output is equal to magnetization. But output is not directly equal to its current input, but output equal to current input plus past history of inputs. So hysteresis is not only what is current input, but the history of the past inputs also. So what happened before still matters now is the simple and fancy way to describe hysteresis. Now we understand what is deadband. When we apply input to any instrument, there is no change in output. It is called a deadband. It is known as a dead zone or deadband. It is a small range of input where the system does do nothing. The input changes, but the system does not respond. Why it happens? Because of static friction known as a friction backlash hysteresis. Example, we can have an example of thermostat. You set AC on 25 degrees Celsius. It won't turn on until the room is hotter than 26 or cooler than 24 degrees Celsius. The range between 24 to 26 is simple way we can change. It's a dead zone because uh, for the small changes are ignored to avoid frequent on-off. What is range and what is span of the instrument? The range is the minimum to maximum value of the physical quantity that an instrument can accurately measure. A 4 to 20 milliampere temperature transmitter is calibrated to measure the temperature from 0 to 100. The range is 0 to 100 degrees Celsius, and the span of the instrument refers to the range between the minimum and the maximum value it can accurately measure. Like range, we can say it has lower range value and upper range value, and span is the discrimination between upper range value and the lower range value. Span helps to define the instrument sensitivity and calibration. Sensors can measure from 0 to 300 psi, then its range is 0 to 300 psi. In other hand, span is the difference between two limits. 300 minus 0 is equal to 300 psi, while range is expressed as two values starting and ending. The span is a single value that shows how wide the measurement window is. Both use the same units as the measured quantity, but span is more likely used during calibration and scaling, while range tells you the full capability of the instrument. What is backlash? It is difference between trailing phase and leading phase of the gear screw. The gap between the connected mechanical parts like gears or screws where moving one part doesn't immediately move another. The smallest error is called backlash. You turn gear but next gear lags before moving. So the error is called backlash. The delay is because of space between gear teeth. That is backlash. Some instrument. What is live zero? It is the term applied to measuring system whose output signal is not zero for zero input quantities. When we apply a zero input quantity, output is not zero. Some feedback transducer systems are designed to develop output signal of the DC current ranging from 0 to 20 milliampere when the input quantity changes from 0 to full scale value. Like zero is the most important definition. Why? Because we set in some instrument, we set 4 to 20 milliampere as a zero for the practical readings of the instrument. Scale readability. As the name suggests, the scale is a full range of value marked on instrument that it can measure, such as a 0 to 100 degrees Celsius on thermometer. Readability is the smallest value that can be accurately read from the scale depending on how closely the markings are spaced. Readability. Readability is the smallest difference in measurement that an instrument can display. In simple terms, it tells you how fine or precise display reading is. Now we will see input impedance and output impedance. In any system, we understand in an electric circuit that what is input impedance and output impedance in detail, but here we have to remember that for any instrument, there should be low output impedance and high input impedance. Low output impedance because to get low voltage drop, and high output impedance because measuring instrument to avoid loading the signal. So in the next lecture, we will study the dynamic characteristic of the system in detail.